MTE 2021 Virtual Edition will be the catalyst in encouraging innovators and inventors to share and inculcate innovativeness and sustainability in their research. Innovation is not just about making new and better products. It encompasses all aspects of ideas, processes, systems, services, methods, and models.
As large gatherings are no longer encouraged, I'm happy to see that MTE has gone virtual. This will allow more innovators and to promote their innovation and share their ideas with the world.
We look forward to university putting a strong efforts to forge strategic collaboration with industry to generate new sciences, innovations, and commercial entities.
There may come a day in the near future when we have overcome this crisis, but our innovations may be able to assist another country in their fight against the pandemic.
To lift student engagement and attainment in innovation and to support teachers and improve student outcome, innovation and technopreneur mind.
Involving youth at an earlier stage is important, especially as Malaysia is slowly but surely becoming a greying nation. Innovation alone is not sufficient. We must also create an infrastructure for incubation of ideas and transform them into successful ventures.
Enhancing not only in the design but also the delivery of public goods and services for the people. Innovation in government is imperative not only to transform but also to stay ahead of change.
The quick responses to protect its citizens from COVID-19 shows the unity of the nation. Know that your contribution is critical to the transformation of our country.
I'm fully confident that this year's MTE IIA, albeit on a new normal platform and approach, has achieved its desired impacts.
It has been nurturing the innovation culture among scientists, researchers, students and startup founders in order for them to transform their ideas into business ventures.
Innovation, as you know, continues to play the important role in the fight against COVID-19 as governments continue to seek to halt the virus spread in the short term, implement measures to aid economic recovery and build resilience to future social and economic disruptions.
I eagerly look forward to learn more about your work for the COVID-19 response so it can be deployed to help the government manage the pandemic and future emergencies. By embracing innovation, we can certainly reset our approach to combating this war.
This award recognizes and honors innovators, researchers, and businesses for their excellence in innovating during a crisis as well as resilience to look outwards and solve problems that the healthcare system and communities faces.
Knowledge Resources for Science and Technology Excellence Malaysia, or CRIS.my, is a knowledge management portal for research and development, R&D. It is spearheaded by MOSTI to address science and technology challenges faced by the science, technology and innovation STI community. Let's explore more with our mascot, CRIS. CRIS.my has 6 main information modules. STI organization provides basic information on organizations involved in R&D activities and other STI-related services. Malaysian Human Resources in STI, My HR STI, contains human resource profiles such as researchers and experts involved in R&D activities in the field of STI. National Scientific Facilities and Equipment, NSFE, aims to encourage the sharing of facilities and equipment and cultivate research collaboration among the STI community. You can also book FNE via portal or mobile app. R&D Project Bank shows lists of information on research, development and commercialization projects throughout the Malaysia Plan, as well as its outputs and achievements. Technology Market, or TechMart, promotes local products or technologies and boosts technology transfer among researchers and industry. STI indicator is used to measure the performance of STI in Malaysia based on goals established by the government. CRIS.my empowers you to formulate STI policies based on STI data, streamline and optimize R&D resources, practice data-driven decision-making, harness scientific knowledge for new invention and innovation. Our new features will allow elastic search, automatic email notification, mass upload, live updates, dynamic report, online booking. Be a part of CRIS.my to explore the explosion of scientific knowledge and information. CRIS, connecting you to the world of innovation.
Ladies and gentlemen, our next lined up program is a knowledge sharing session. Please enjoy.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Rozi Ahmad. I'm from the Faculty of Applied Sciences under the Textile Research Group, and this is a topic that I would like to talk about electromagnetic shielding, textiles for protective clothing for human and device protection. So throughout the presentation, I will use EMS, the abbreviation EMS, which means electromagnetic shielding. Okay, what are EMS waves? They are actually oscillation of electric and magnetic fields in a linear path with constant velocity, and they travel perpendicular to each other to the direction of the flow, and they can also travel at the speed of light, and of course below that if they are traveling in any other medium. And talking about EMS or waves, there are actually 2 types of waves, which are called the non-ionizing and also ionizing. Ionizing waves are those which have higher energy, and for example, if you talk about infrared, ultraviolet light, X-ray, gamma rays, and those are under the category of ionizing, okay, which are sort of harmful to humans if you are exposed at a long duration. For non-ionizing energy or waves, okay, these are considered as low energy frequency. For example, the handphones that we use, the radios that we use, the Wi-Fi, and things like that. So these are considered as harmless for now, but later on when we are going towards 5G, so this kind of energy, okay, would be sort of a little bit worrying, okay, for some scientists, because of the effectiveness of these waves, which can be harmful to humans. And what are the sources of waves? Okay, these are some examples of the sources that we have. Okay, every day, everything around us consists of energy waves. Okay, of course, as I've mentioned before, from the handphone that we use, the radios that we listen to. Okay, this all generates energy waves. Okay, which are for now is harmless to humans, but as well as those waves which can be considered as harmful, okay, as I've mentioned. And for example, from nature as well, okay, we have the thunderstorms, okay, which can also generate a lot of energy there. And of course, in our house, you know, everything is there. You have your TV, you have your washing machine, you have your microwave, okay, you have your radios, handphones, for example. Okay, this all generates energy or waves around us which we cannot see. So if we can see these waves, I think we will not go out from our house, okay, because we might be too afraid to go out. Okay, so what are the effects of these electromagnetic waves to humans? Okay, from studies, it was found that this electromagnetic radiation, or EMS, okay, is the fourth most serious source of public pollution, behind noise, air, and also water pollution. So studies have shown that these waves can, you know, affect humans in terms of headaches. If you realize that you got headaches by now, probably it's because of the radiation from these waves. Okay, insomnia, fatigue, dizziness. Okay, some may also give brain damage or DNA damage, and it affects the cancer as well, and also fertility. So these are the effects of if you have a long exposure to these waves, okay, for a long time. Alright, there are some studies, as I've said, scientists have already done many studies about these waves. Of course, we cannot avoid these waves, waves, because we need all these technologies around us, especially nowadays. But you know, because of the effects to humans, sometimes it's not good to put your handphones in the pocket. Okay, especially men, if you put it in your pocket, okay, may cause fertility issues in the future. And of course, if you look at all the brands, for example, Apple already warns us about, you know, if you carry the handphone, it should be at least 5 millimeters away from your body, or probably a little bit distance from your ear. Okay, so these are some warnings given by manufacturers, okay, to the consumers, which the general consumers do not realize all this. For another example is Samsung. Okay, also it mentions there very clearly, okay, it should be a distance of about 1 centimeter away from the ear or from the body. So that's also another warning there given by a very, okay, very big brand. Okay, and another example that I can give you is about this, you know, monitoring system that if you use in your house, it should be, it says there, it should be approximately 20 centimeters or more away from the baby, for example. Okay, and if you use wireless printer in your house, so it's also, there's a warning there. It says that it should be, okay, more or less more than 20 centimeters away from humans, okay, during normal operation. Okay, so what the topic that I'm talking today is about electromagnetic shielding, as I said, or EMS. So of course we need to protect humans especially, okay, from these waves, and of course not only humans, the devices that we use every day. That's why if you look at the wires, if you have in your house, okay, it's always coated with something, probably PVC or any other sort of materials. So these are used to protect humans, for example. Okay, so they want to avoid as much as possible waves, okay, from the wires, okay, dissipating to the air. Okay, so there are many types of EMS shields used in the market at the moment. It can be in terms of, for example, the Faraday's cage. Okay, you have the metal cages which are used to conduct the electricity, and also coated fabrics, or for example, you have paints, okay, conductive paints, for example. And one of the things that I would like to bring today is about conductive textiles. Okay, so why textiles are used as the conductive material? Because they are flexible, okay, they have that porosity, it is light in nature, it has good air permeability, and it is corrosive resistant, the cost of production is low, and many other things. Okay, so that's why, and of course it is, the main thing is it is flexible and can be used as clothing. Alright, the types of conductive textiles, I'm going to talk about the multi-component yarns and also the multi-component fabrics, for example, but there are also conductive fibers or filaments and also fabrics which can be coated, okay, by using conductive materials. So I'm going to talk more on the multi-component yarns and also multi-component fabrics. Okay, in terms of the research that we do in UiTM at the Faculty of Applied Sciences, we sort of produce this particular multi-component yarns, okay, from the machines that we have. It can be using multiple fibers, okay, in the core sheet or core or wrap spun yarns, okay, for example. So these are some diagrams to show you the exact pictures of the materials that we produce in the lab. Okay, so some of the features of these multi-component yarns, it should be at least 2 components, and of course one of the components should be a conductive component. So for example, you can have like metallic fibers and filament, or you can have like carbon coated fibers and filament or conductive polymers, and it can be produced or spun using many types of technologies, okay, for example spinning, which eventually you can also weave or knit them, okay, using machines. Okay, just to give you some illustration, okay, of the components of a core spun or wrap spun yarns. Okay, the example that I'm showing you is like, for example, you have spandex as the core, and you can wrap the spandex with another component of fibers or filaments. That component can be substituted with conductive element. Okay, so or you can have like core sheath, so where the core is the conductive material and it is wrapped by spun yarns or any other materials, okay, which can help to give the softness or flexibility, okay, on the yarns. Okay, so why do we do this? One of the reasons is that because when you have a conductive material which is normally quite rigid, okay, being woven or being knitted into a fabric, the issue is the increment of the gap or the spaces, okay, within the fabrics, okay, whenever it is bended, or if you have that curvature, okay, on the fabric, it will sort of give some increment in terms of the space. So that is where you have the waves passing through. That's the main problem, because the wave can pass through the fabric. So that's why it is good that this research is to find a solution to this, where we can reduce the gap even though the fabric, okay, is bended. Okay, so how do we overcome this? Okay, we look at this particular yarn structure. Okay, this is a 3-component yarn where we have a copper wire which is wound, okay, onto the warp yarn or the weft yarn, where we can reduce as much as possible the spaces, okay, as I mentioned before, so that you can sort of not allow the wave to pass through that easily. So that is the research that we do. So I'm going to talk about that a little bit more. Okay, in terms of the sample preparation, we have we have used copper filament, which are flexible copper filament, okay, very fine diameter, and we also use polyester yarns in this case, and we sort of spin these components okay, through a machine which is called the hollow spindle spinning machine. We can do it in two types. We can have the core component, or we can have the covering component, and this is how the machine looks like. Okay, part of the component of the main components, okay, on the machine. Okay, this is hollow fancy yarn spinning machine, and these are the sort of examples of yarns that we produce. Okay, so we can have, of course, many parameters that we can look at. For example, the number of twists that you can give, or the copper diameter, you can vary that as well. So in the end, it will produce the core or core spun yarn, or core or cover spun yarn. Okay, and then of course, after you produce the yarn, we will use a weaving machine in this case, okay, to weave the fabric into a suitable size for testing. And we can also use the hand loom, okay, but the hand loom, of course, you have to do it manually. So normally we'll use the machine that can produce the fabrics at a much faster rate. And after weaving, of course, we have to test, do some measurements on the fabrics. So this is one of the measurements that we did, okay, which is looking at the image using a modified puncture testing arrangement. Okay, so from this arrangement, we can eventually look at the gap or the spaces, okay, between the yarns in the fabric whenever there is some bending occurring to the fabric. So we look at how the fabric, or how the spaces, whether they becomes bigger or larger, or it is okay. Okay. All right. So this is just to show you some results that we received. We got. So for a conventional fabric, okay, it will increase, for example, up to 206% if after some 20 millimeters deflection before it ruptures. So if you look at the graph, okay, about the same average load, okay, the cell size increases, okay, for the conventional fabric. But for the self-locking fabric, we call it self-locking, the fabric that we produce using copper wires and also polyester yarns, you can look at the same load, okay, the increase in cell size is not that big. Okay, so there's some reduction in the cell size, as well as the deflection and the penetration. Okay, it is, although not only it is able to reduce the cell size, but it is also sort of stronger because of the copper that we have. So the deflection is quite small for the fabric that we produce. Okay, this is another test that we conducted on the fabric, which is looking at the yarn pull out behavior. Okay, it's just a simple test to pull out and see how much force is needed to pull out any of the yarns in the fabric. So you can see from the graph, okay, obviously the self-locking fabric, okay, have to use higher force to take out or to pull out any of the yarns within the fabric compared to the conventional fabric. And as for the EMS test, okay, this is a test that we conducted in collaboration with the Faculty of Electrical Engineering, and we use a lot of setup here. Okay, if you look at the picture that we have, okay, the sample is in the middle, and there's a receiver antenna and a transmitter antenna. So the transmitter antenna will just transmit energy or waves, okay, and the receiver antenna will receive. So we will monitor how much wave can pass through the sample, okay, and that is how much wave is captured by the receiver antenna, so that we can measure the effectiveness, okay, towards electromagnetic shielding. And this is the actual setup. Okay, the sample is in the middle. If you can see there, we have the transmitter antenna and the receiver antenna, and of course we have to conduct this in a special room, okay, without any interference of noise and also any other interferences. There are two ways that we can do this. Okay, if you follow the ASTM D4935, okay, is using the coaxial probe, where you put the sample in the middle, and it can also give some measurement, okay, on the electromagnetic shielding effectiveness. And also another setup is from the IEEE standard 299, okay, similar with as the previous one. It's looking at how much energy or waves can be absorbed by the sample after the radiation is released. And this is some tables to show you the grades, okay, that we give towards the to show the effectiveness of the EMS. So for example, if you look at for standard class 1 applications, and there's also another class 2 applications, for if the decibels, okay, of the result is, you know, they can sort of block more than 30 decibels, okay, that is considered as 99.9% effectiveness. So if you have this sort of fabric, then it is good for EMS shielding radiation. And there's another one which is called the class 2 applications, okay, for much higher applications. So of course the EMSE, okay, or electromagnetic shielding effectiveness is higher in terms of the decibels, so more than 60 decibels, then that can be considered as 99.9999%, okay, percentage effectiveness. So these are just to show you the standards that we use to compare our samples. Okay, I'm just giving you just one example, okay, of the results that we received for the fabrics. Okay, FC3 and FC2 are just some abbreviations that we give for our samples. So if you look at different gigahertz or different energy levels, you can see that the effectiveness of the fabrics, okay, is good at, for example, in this case at 4 gigahertz. Okay, so at 4 gigahertz, it is giving the, you know, sort of the maximum the decibels. So meaning that if you look at compare the results that we have, okay, and the grades that we can give them, it is considered for example, I'll give you the results in the next slide. So it can be considered as excellent level of protection for class 2 for general use, class 2 applications, and for professional use is considered as moderate level of protection. So you can see the effectiveness is more on the 3 gigahertz to 4 gigahertz, okay, and so as the attenuation percentage power. Okay, so these are the end results, okay, of the project. So of course we have collaborations with a local textile company to produce the fabrics, okay, after we see all the results. So this is just to show you rapier jacquard weaving machine to produce the samples. Okay, so it is a huge industry based machine. And in terms of the applications, okay, these are some applications of this sort of fabrics which are used to block radiation, especially electromagnetic radiation. So it can be used as curtains or camouflage tents. It can also be good to use for wallpapers, especially in hospitals, and also pouches, okay, for our clothing to avoid radiation from the handphone, for example, and also for building inlays, which is also very useful for new buildings to be built. And there are also some commercial conductor fabrics available in the market. For example, the neck warmer that I'm showing here, the brain coat. Okay, so there are some are coated materials, some are, you know, like the one I'm showing here, silver lining T-shirt. It is just a T-shirt, okay, with a nylon mesh, so which is conductive. Okay, and also cap, okay, consisting of polyester cotton blended yarns. Okay, and they also embed microfine stainless steel fibers within that to make it conductive. And of course, the end product not only for conducting purposes, but it can also use for smart fabric applications. So this is going to be another area that we are venturing into with European partners under the Erasmus grant. I think that's all from me. Thank you very much. Have a good day.
Hi everyone, I'm Winie from University Technology Mara. My research interests are solid-state ionics and energy devices. Today, portable electronic devices have become part of people's everyday lives. If you get on any transit system in any metropolitan city, you will see many people around you immersed in their portable devices. With our dependency on technology and portable devices, how can we keep up with powering these devices while we are on the move? All devices are powered by electricity. How do we make electricity portable? Well, today, I would like to talk on energy in a portable world. Portable electricity or mobile power, it is a general term that may refer to an energy system that integrates packs of smart batteries, supercapacitors, solar cells, or various combinations of them. Mobile power is accessible off-grid energy source. It should be clean, affordable, lightweight, high quality, and convenient to use. Now, let us begin with the solar power. Solar energy is the most abundant energy available on Earth. The amount of solar energy that hits the Earth every hour is sufficient to power the entire Earth for a year. Photovoltaic conversion using solar cells is the convenient way to use solar energy. There are various capacities of solar cells to power various devices. Generally, there are 3 generations of solar cells. The first generation solar cells were reported in 1954 at the Bell Laboratories, where a silicon semiconductor-based material was used to draw electricity from light directly via photovoltaic effect. They can be divided based on their crystallization levels, the monosilicon and polysilicon. When light photon was captured and absorbed, it generated charge called the electron hole pair. These charge carriers were then separated and extracted into external circuit supplying electrical current. Solar cells based on crystalline silicon wafers are currently dominating the market due to its high efficiency. These silicon cells are demonstrating high efficiency in the range of 15 to 20%, and they are highly stable. On the other hand, third generation solar cells started from 1991, mainly based on organic materials, organometallic compounds, or inorganic materials, but have not been commercially proven yet. Example of this solar cell is dye-sensitized solar cell. For short, we call it DSSC. DSSC uses dye as sensitizer to absorb sunlight, producing excited electron, which is then injected into the conduction band of titanium oxide and connected to external circuit. The main attractive feature of DSSC is it is simple and economical. Small-scale commercialization has started for indoor applications and consumer electronics. Several industries are in the process of carrying out pilot production of DSSC. Preparation for large-scale commercialization is underway. At least an efficiency of 15% is needed for large-scale marketing. Well, from solar cell, let us move to battery. The first battery was believed come only in 1800. It is known as voltaic cell. It was made by stacking zinc and copper discs separated by paper soaked in high concentration of salt water. Smaller size and lightweight cell was later demonstrated in 1868. The cell composed of zinc anode, manganese dioxide cathode, and low corrosive ammonium chloride solution as liquid electrolyte. After some years of effort, the inventor successfully substituted the liquid electrolyte into an electrolyte paste, giving birth to dry cell concept. Building on the dry cell concept, few major advancements were made based on new materials to increase the power loading. The launching of lithium-ion batteries in 1991 by Sony was a huge commercial success. Lithium-ion batteries beat all its competitors in terms of cost, non-toxicity, long cycle life, and environmental friendly. In the market, there are primary and secondary batteries. Primary batteries are non-rechargeable. They utilize their stored energy one time in a single discharge cycle and then are discarded. On the other hand, secondary batteries can be charged, discharged, and recharged many times. Therefore, they are known as rechargeable batteries. Secondary batteries, ranging from lead acid, nickel-based, and lithium-ion based, powering almost everything from portable devices to hybrid electrical vehicles and electrical vehicles. Many believe that electrical vehicles might be the solution to greenhouse effect. They will give better air quality in mega cities and improve health. The Paris 2020 agreement has been a big motivator for the adoption of electric and hybrid cars in Europe. Countries in Europe such as France and Germany have committed to banning all non-electric cars. Most of the mobile device users concerned of their device battery level, especially when they are out of office or home. However, not many users will care much about the battery eventual lifespan. In fact, most smartphone manufacturers tested their device for 300 to 500 cycles. After a threshold cycles, the batteries are no longer able to hold as much electricity as the first 100 cycles. As a result, it could not deliver the rated capacity as indicated in the manual and would only be able to power device for a shorter period. Well, there are always ways to keep battery in tip-top condition for a longer lifespan. Battery lifespan does not only depend on the type of battery and its quality, it also depends on how the battery is cared for. For primary batteries such as alkaline AA and AAA batteries, it is always a good practice to keep the batteries in a dry place to avoid corrosion. Do not attempt to recharge primary batteries as it will likely cause battery failure and explosion. Batteries should also be removed from device after use because many devices don't power off completely on switch off mode, causing battery leakage. Lithium-ion batteries are so popular in home appliances, mobile devices, and become an inseparable part of our lives. Under normal circumstances, lithium-ion batteries can usually last up to 5 years. Like other batteries, proper management is required for lithium-ion batteries. One good practice is to partially and fully discharge the battery at a regular time slot. This will reduce the building up of internal resistance and maximize the operational lifespan of battery. Do not put the battery in an elevated temperatures environment such as a hot dashboard and long duration of plug-in to power socket. This will lead to cell oxidation and will reduce battery capacity and might shrink the operating life of the battery. For long-term storage, it is better to keep it at partial charge rather than fully charged or fully discharged. Recommendations from manufacturers are to drain the fully charged battery to 40% or to charge up the empty battery up to 40% for storage of few months. This level of charge enables low degree of self-discharge and at the same time able to maintain the protection circuit powered. Every device comes with its respective charger that has been preset with a charge current rate. Therefore, consumers should use the appropriate charger to deliver the right amount of current to the battery. In modern day world, millions of batteries are spent annually. All used batteries are considered hazardous waste. Batteries consist of many materials. Some heavy metals, corrosive and toxic chemicals are potentially hazardous to health and the environment. Improper disposal of batteries by throwing into garbage bin could result in soil contamination and water pollution, while burning in open space could vaporize heavy metals such as mercury into the air. Recycling aims to minimize the number of batteries as technological solid waste. It keeps them out of landfill and combustion facilities, prevents pollution, saves energy, and helps sustain the environment for future generations. Sorting process is the main challenge for battery recycling as batteries are made from many different materials. But bear in mind, AA, AAA alkaline batteries are recyclable. The metal steel casing and electrodes could be recycled or reused. The steel could be cleaned and separated from any impurities and sold to secondary steel markets for new production. Other components would undergo high temperature refining process. Besides alkaline batteries, car batteries containing lead should be brought only to waste management centers or back to the retailers, where they can eventually be recycled. Remember, recycling of electronic waste is important in order to prepare a better future for our next generation. Last but not least, in UiTM, we have a group of researchers work on batteries, solar cells, and supercapacitors. Our research activities focus on preparation and characterization of anode and cathode materials, as well as detailed study of electrolyte materials. Till then, thank you for watching. Bye and stay safe.